I don't want to say you don't want microservices, but you certainly want to limit them to the ones where the value justifies the on-call rotation that it's going to need.
This is DevOps Paradox, episode number 214, taking SQL to the next level with Materialize. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, when we're starting out developing applications today, where do you normally start? Web, mobile, CLIs? Where should people start?
They should start with anything but Perl.
No, wait. Why are you hating on Perl?
It's a long-lost love that I don't want to meet anymore.
Well, I'm sorry to put you in so much pain. I didn't mean to do that. But where do you think we should start? Where it should be? If you're doing CLI work, you should do a CLI and not web.
A bit of backend, maybe?
Some backend. You're probably doing Go.
It must be Go. If it's not Go, I'm signing off right now.
If it's not Go, you're
I'm
gone? Okay, never mind. Why are we talking about this? What about data? Where should we start with data? We've had a lot of people on recently talking about data, right? We had Sam on from Planet Scale. We've had other people on, and it's like, okay, we're talking just normal data, but it goes a lot further than that, doesn't it?
Okay, that data. I thought that you were going to ask me about all the data I gave to Facebook, and I'm not going back. So not that data.
No, you can block that data, but we're not talking about. Okay, that's not the day we're talking about. Today we have Arjun on from Materialize. Arjun, how are you doing?
I'm doing very great. Thanks very much for having me.
And sorry it took so long to get to you because Victor just wasn't playing along with me today. I don't understand why it was taking so long to get him going.
Victor is never easy to deal with.
So thinking about this, right? When you think about loading up maybe a relational database, no, just go with me for a second, Arjun. Loading up a database, you're doing maybe ETL, or you're doing some other kind of just normal batch load from whatever. But it's 2023 now. Where should we start looking?
Oh, I would start right there. I love relational databases. I used to work at Cockroach Labs working on CockroachDB, a relational database. I think most applications should probably start with a relational database at its core. The problems start to come up once you've got that core thing going, and then you want to add some other things. Maybe you want to send that data somewhere, do some analytics, and then you want some caches, and so you've got some Redis clusters running, and then you got to move data from point A to point B, and so you've got some Kafka, and now you've got about 14 problems, right? So I think the longer you can keep it in that relational database without introducing all these complexities, the happier you're going to be. Well,
it feels like if I added one more thing, I wouldn't have 14 problems. I'd probably have 39 problems.
That's unfortunately how it goes. A lot of the problems they compound in these disturbing ways because we're really talking about the intersection of these systems and the intersection of three systems and the consistency problems that come from combining these systems and trying to reason about data that went in one end and came out the other, transformed three different ways. Absolutely. That's a lot of the pain that I've seen and many of the folks that I hang out with see on a day-to-day basis, and it is not pleasant.
So you said consistent there for a moment, and I just had a very bad flashback to CAP theorem. Some people think that's dead and gone. I'm saying it's always been a zombie. Where do you fall on that?
Consistency and isolation are things that relational databases have done a lot of heavy lifting for a lot of people. And so these problems have faded in the back because people have had a good time for a while. I think we saw with the NoSQL years when people abandoned relational databases for more complex systems. They did that for good reason. They did that because the relational databases of the time weren't scaling. And then you saw that like, I think zombie is an appropriate metaphor, which is it's never really gone. It awakens and comes back for you when you least expect it, with the slow, relentless march of the anomalies and the bugs chasing after you, ruining your data. We've learned some lessons at high costs. And I think people have a little bit more of a mature take now, which is those aren't things that you can ignore, and they have to be foundational concerns in your data architecture. As you're building out your data architecture, they can return at a moment's sloppiness. You let your guard down just a little bit, and now you're back to thinking about that. Nobody wants to be thinking about that. They want to be getting stuff done.
To me, that's what you just said is interesting, because you just said we had NoSQL years due to certain problems of SQL databases at the time. You mentioned scaling. But then from developer perspective, right, the appeal of NoSQL was more, I can shove anything I want into it, rather than necessarily this does not scale, right? And now we see going back to SQL, at least I have impression that we are back to that's not so important anymore, so why not use MySQL or Postgres or something like that?
To be fair, I think the SQL databases today, they may share the same names as they did 2 decades ago, but they've come so far, right? Like the SQL databases today, the Cockroaches, the Planet Scales, and even just Postgres and MySQL, they are so much more capable today and are delivering so much more throughput at strong, consistent layers that it is possible to not have to revert to NoSQL, except there's always folks who are just at the absolute outer limit of scale, right? The Facebooks and the Googles who are always going to be building custom systems for their own needs. But for most people, today, what you can do with a Postgres or a MySQL in the cloud is far more performant and scalable than what they were able to do. So I don't want to say they made the wrong trade-off picking various NoSQL systems. I think that's probably what they needed to do to get things done. And like you said, it was a place to put your data. And if you have so much data coming in, you find a place to put it, and then you figure out the problems later. And then you maybe find out that there's a lot of problems. It slows you down, right? Like having to deal with that, having to reason about every single code change. What is it going to do to all of these different combinatorial code paths, and having to reason about what are all the other code paths hitting my database doing? What about if they partially commit and I have to roll them back? If you don't have support for this at the database level, you do have to manually write it. I think, I don't know who came up with this first, but it isn't me. The saying is, you don't want to find yourself accidentally building a database when you're under-resourced and don't have the time. It's not that databases are this magical thing that you need, the men in the black suits with the sunglasses, and only they can build databases correctly and the rest of us mortals can't. It just takes time, and it takes a certain amount of person years to build right. And you certainly don't want to find yourself being like, oh, what I really need is transaction rollbacks in this situation, and we kind of have to roll our own application code. That's when you get into trouble, right? And that's what a lot of folks who adopted NoSQL said. So it made sense for the first use case. Well, I just need some place to dump these keys and values. I'm going to get a key value store. That makes perfect sense. And then as the queries, the paths gets more complicated, and you're doing some joins in the application code, that's when you start finding trouble. That's when the trouble starts.
Now, when we started out, we were talking about basically batch loading. But you've also said Kafka, and that's real time. There's other real times too. I mean, think about it. You've got mobile, you've got the click streams of, Victor on Facebook, all the clicks, and now people want to get that data fast, immediately. Old school, like what we're talking, would be a batch load. But now it just needs to be there. Is that what everybody should be thinking about?
Absolutely. I have a dog in this fight, right? Materialize is a database that's purpose built for the streaming low latency users to deliver analytics or OLAP quality queries, so the complex joins, the really complicated SQL queries that are kept up to date within milliseconds of the underlying data changing. And that oftentimes means data that is being fed to us via Kafka, but also from relational databases, change data capture, things like that. And this is the user expectation today, is that all parts of your application or your website are aware of all the most recent bits of data. It's really frustrating when you get an email with an order confirmed, and you go to the website and it's not there in one of the various views that are there on the website, because that system's being fed through some. It's a little bit like, at least my perspective, a little bit like the that scene from The Matrix where he's looking at all the flowing bits, and he says, I just don't even see the code anymore. I just see a person and another person, and I feel very much like I don't even see the website anymore. I just see broken ETL pipelines and a failed batch load. And you see this all the time when you encounter an application where the left hand doesn't know what the right hand has already confirmed for you, because fundamentally their back-end infrastructure is running from slow, and users are no longer sort of willing to tolerate this. And you see the most recent and the best applications today are moving everything around in real time so that every part of the system is up to date. And of course, now you've reintroduced all of these problems, right, of consistency, right? How do you move data from system A to system B? You've got multiple databases, and the user is expecting transactional consistency from the experiences that are spanning multiple databases. And this is the sort of thing that we really sweat the details at Materialize. Materialize is a database that gives you consistent, up-to-date views, right? Views in the SQL sense of a view over changing data that is always up to date when pulling from disparate systems, be they coming from multiple shards of Postgres or MySQL, or coming from Kafka and from MySQL, whether they're the event streams and whether they're transaction data. You can construct these nice little materialized views, which is why we call it Materialize. That's sort of the business we're in, is creating materialized views for people to not have to do that in their application level code, because it's hard to get a consistent experience out of that.
So let's imagine for a moment you're the person tasked with coming up with the way to go ahead and assume Materialize doesn't exist, right? So flush that out of your brain for a second. You're the person tasked with going through your scenario. I placed an order, I got an email, I'm going out to the site, and I don't see it. Where do you start today? Again, Materialize doesn't exist.
Now, typically you might go in and say, well, the order taking thing is a transactional database that is automatically triggering an email. That is pretty instantaneous. We take your money, we send you an email. And then there's probably some other part of the site that's being powered by some other service that is getting the data from that database on some slower schedule. And that's probably why that other service could be anywhere from minutes to hours before it reflects that in its systems. And you'd have to speed up that pipeline. So you might make that lower latency by putting in place Kafka, right? So Kafka is excellent at getting data from point A to point B at low latency. The challenge is working with that data is not often easy. So you might have to, modify a microservice, write some code to reflect as those incoming messages come on that Kafka topic, to update incrementally in real time the outputs of that cumulative set of messages on that Kafka topic, so that when there's a request that comes in to load that data, it is as up to date as can possibly be. That's hard work, right? So that is essentially you are writing view materialization code by hand, and depending on the complexity of the view that you are trying to surface, potentially challenging. You might have to, for instance, join data coming from multiple Kafka topics. Now you're essentially writing out a join algorithm by hand, which you might get wrong, or you might get some edge case wrong. Or even if you get it right, it just takes a while, it's a lot of time to get that right.
And you may have some index issues.
That's an excellent point. In fact, you might have to bring in a NoSQL system to store the state where you are manually building that index. That we see a lot of, which is, it's not just that I'm building a microservice, I'm building a stateful microservice, and I need something that'll keep the state. And a key value store is actually an excellent thing for this. In fact, many databases use key value storage under the hood, because at low latency updates, you do sort of need that raw format to put the data exactly where it is and do the lookups exactly as you want them to at very low latency. But you can get that wrong. And now you also have a stateful NoSQL key value store that you need to keep alive.
So as a developer trying to fix this problem, and notice I said the word trying, you've had to introduce Kafka as your first step. Actually, some microservices that are using Kafka. You realize you've got still even more latency you got to do. Now I've got to introduce a key value store to help mitigate some of that latency. How many people do you think coming off the street can actually build that today?
I think that's the real challenge. The pool of people who can manage this is small. So I think most of the time people who find themselves in this situation have this terrible recruiting problem, which is first of all, the team needs to be at least, 4 or 5 people, because you're going to have enough people to carry a pager to keep all these things alive constantly.
Wait. A pager? What's that?
A thing that hopefully you don't have anymore in your life.
The current analog for that is a text message, just in case you didn't know what a pager was. Okay, continue.
Staffing this team is hard. It's expensive. You probably don't have budget for it or the ability to recruit a team to do this. You're probably cobbling together various AWS services or cloud services. So you have a fully managed Kafka, a fully managed Redis, a fully managed microservices orchestration framework. And you probably at this point are regretting getting into this position or are looking to simplify rather than complexify by adding one more thing into it.
So now that you've realized that, is this when you turn in your resignation and move on to the next thing? Probably so, because you've been backed into a no-win situation. Okay, it's not that dire, is it?
No, it's kind of fun.
What you laid out there is real life, right? Without Materialize, and again, we're trying to keep that off the table for right now. You're going to have to do some sort of big re-architect, no matter what. And of course, and Victor, I'm getting ready to pull you back in. The answer to this is always going to be, let's put Kubernetes in. I'm thinking Gilbert pointing at the boss right now.
Not for a database.
Right? Kubernetes is going to solve our problem. Okay, I know not for the database, but moving data around, people will say, hey, it's going to give us scalability and all the other abilities that we would typically want. And that's just not true, I don't think.
I'm a huge fan of Kubernetes, but I'm also even bigger fan of somebody else managing stuff. Meaning managed services, right? Whether that's by some other team in my company or some provider. And that's especially true for databases. I just don't want to manage them. Somebody has to. Just let it not be me.
Well, that brings up an interesting point too, is if you can get a managed service, you should. If you can't, then where do you go next? What do you think about that, Arjun? At a higher level, take off your Materialize hat for just a moment. What should a person do if there's managed services that will do exactly what you want, but you're not allowed to use them for reason X? What do you do?
That to me feels like a no-win situation, because I would really do whatever I could possibly do, move heaven and earth to get the sign-off to use the managed services, because downloading, installing, and keeping alive, it's the keeping alive that's hard. The prototype is not that hard to build, because there's wonderful software that you can download. And you can have it all running in a Docker Compose set up on your laptop in a day. And the problems all come, the hangover that comes after.
Day 0 is good. Day 1 is even good. Day 2, you realize, what did I just do?
Actually, the fact that, especially today, day 0 is so easy, very often leads people to a wrong path. Kind of, first day, easy. Hence, you go to the next day, easy, easy, easy. And then you get to the situation where you have a strong desire to open a window and jump.
I would say that, if what I would do in this situation is do whatever possible to do everything in Postgres. So as much as possible in a single system that's flexible and at least has a path to if I can't convince people to use a managed Postgres today, maybe after the second outage, I can make my case, and then at least the migration will be easy. That would be what I would try.
That's definitely the important point, right? Because the more we self-manage, the stronger there is need to rally around as few of tools as possible, right? And I'm not necessarily talking exclusively about databases, but whatever that is, right? I cannot allow myself to have 10 different types of databases because that means much more work making sure that it's running. Just as I cannot allow myself to run Mesos and Kubernetes at the same time, right? I'm ignoring now that Mesos is non-existent almost, right? And that's very different from managed services, right? Which allow me more opportunities to pick the right tool for the job without having a considerable overhead in managing those tools, right? I can easily spread myself across 20 different databases if that's managed. I mean, there is always some work, so I'm old enough to know that manage is not really, there is nothing for me to do, but the cost is significantly lower. It allows me to explore options in a way.
Absolutely. I agree. I agree with that. The incentives are changed with managed services to use the right tool for each job, which is where you want to be.
Now, you called out specifically Postgres, like you were hard and fast Postgres. Why do you say Postgres is better than, and I'm going to take it one step further, why do you think the Postgres wire protocol, I'm assuming that's where you're heading with it. Is that true? Or is it beyond that?
I was just making a religious affiliation statement. I will not pretend to be unbiased here. I am very happy with Postgres. I think the query language is very well designed. It has fewer footguns. It has fewer. No system is perfect. Nobody made all the right decisions 15 years ago when they came up with something that we now have to live with backward compatibility to. But Postgres has been, I would say, one of the, or in my view, the sanest in terms of making careful decisions that build towards a cohesive product and a cohesive development experience. And if you look at some of the historical decisions, so MySQL has greater adoption than Postgres, and a lot of it was down to operational gaps in the Postgres ecosystem that have since been closed. So for instance, 10 years ago, MySQL replications and setting up read replicas was far more polished than doing so for Postgres. And if you can't run a good, trusted read replication setup, that's a major barrier to the adoption of a database because you use that as a get out of jail free card for a lot of loads, spiky scenarios. But those have since been closed, and the Postgres ecosystem has caught up on those operational aspects, and the advantages that it has now in having a really principled SQL dialect that is beautifully designed are starting to, for instance, some of the semi-structured JSON operators, the non-relational, the ability to work with non-relational data in Postgres is beautifully designed, and it's really the best of both worlds. You can throw in a lot of keys and values and write SQL queries that get the relational structure out in your query language, in your application really well. I think there's little reason to look beyond Postgres for that day one prototyping experience. And of course, we can make the case for introducing other tools that are purpose-built for the task at hand for other uses. But I have a religious affiliation here, and I'm wearing my biases openly.
I'm curious about one thing that you said, that MySQL has bigger adoption than Postgres. And I'm asking this as somebody who is not really that much into that world. I have impression that, so is that statement valid for the overall adoption, or it includes, let's say, last year or two? Because I don't know whether it's random, but I see Postgres being actually more often chosen lately as a as a new database, let's say, for people starting. I have impression, not based on numbers, as if actually it has a higher adoption if it take only short period of time. I mean, short, like a year or two.
I would not be surprised. I would be happy if that was the case. I think I'm looking more historical. It's hard to get data on this, right? We're using proxies. Yeah.
Yeah.
So I want to go back to something you were talking about during your evangelization of Postgres there for a moment. You were saying the sane part of Postgres. What do you still think the insane parts of Postgres are?
There's still a certain trepidation in recommending a system that is going to tap out at a single node. There isn't a way to get a multi-node scale out Postgres without a hard migration to a cockroach or a planet scale. That is not just a scalability concern, that is also a operational concern. So take cockroach, which I'm familiar with since I used to work there. It's really nice to be able to do a rolling upgrade where you add some nodes, you migrate the load, and then you turn off the old nodes. It makes version upgrades easier, security patches easier. If you're running it in the cloud where you need some powers that be tell you that your node is going to be turned off, your container will be shut down as of this date, you may not have the ability to move a Postgres instance with zero downtime.
How do managed providers like AWS, RDS, how do they solve it? Are they running Postgres or a variation of it? Or
So RDS has a custom underlying hardware architecture for RDS that is not available for you to buy separately as a so I think RDS is doing something special.
Okay.
Of course they are. That's what we're paying them for, right? I mean, that's
true.
That's the beauty of open source, is somebody can take something, make it to where if people need this feature and they're willing to pay for it, I got it for you. I'm actually okay with that not being available in open source. But it would be nice if there were vendors that actually had that. Oh, wait, there are. Self-managed. See, I'm still a self-managed person. I'm one of those that just enjoy the pain, I guess. I appreciate fully managed, but self-managed is still important to me. I don't know why.
Makes you feel more valuable.
Well, that takes us, yeah. I mean, that takes us back to the story there of the developer trying to piece together Kafka and having to get the key value store and having it, so you feel like there's no way you could be let go. Trust me, there is a way you can be let go. Been there, done that, got the t-shirt.
But ultimately, holy grail, I feel, should be that developers at least shouldn't really have to worry about those things. Ultimately, from a developer perspective, right? I care whether my code speaks with Postgres-like interface, right? I shouldn't be that much concerned whether it's Postgres there or some other Postgres. I'm more focused from developer perspective on interfaces, right? I really care that I have an interface with whom I communicate and I get what I need, and the rest is somebody else's problem, right?
I think that's an ideal we'd like to get to. The problem comes when there's performance differences when you swap out the backends. It's never a perfect swap out, right? Like and when there's a, I don't know what the quote is, but eventually the quantity difference that's large enough turns into a quality difference that is, a completely different experience whatsoever, right? Like enough orders of magnitude of latency on some critical path turns into, it's an unviable switch.
Let's go back into the reality where Materialize exists, because it does. Are you willing to share a little bit about how that actually, we were talking about RDS probably has or does have their own flavor of Postgres to do things. How are you running a SaaS? That's your day job, is to run a SaaS for doing materialized views. Correct?
Correct. And I'd love to explain, Materialize under the hood has a pretty sophisticated stream processor at its core. We are experts in stream processing inside. We don't think that every user needs to be. They might want to be, and that's great. And they might want to use a stream processor to do certain microservices manually, because that is a core competency of whatever they are building, and that is fine. But there's an 80-20 rule. There's an 80% of these streaming microservices that are, morally speaking, just materializing a view over some incoming data. And people should be able to do that with this nice, familiar interface of writing a SQL query in the Postgres dialect. So Materialize is Postgres wire compatible. We go to great lengths to maintain a rich set of compatibility to Postgres's beautifully designed query language. So you might want to say, hey, I've got this thing that runs in batch. It's a 5-way join with 2 subqueries and some group bys, and you know, it's 40 lines long, and I need this thing always up to date. Materialize lets you maintain a materialized view of an arbitrary SQL query within milliseconds of the underlying data changing, which is very useful for keeping these interactive experiences in your application always live and up to date, so that there's no discrepancy between what the OLTP system acknowledges, because the OLTP system, being the source of truth, may fire off a confirmation email. And then it's about keeping these downstream materialized views completely in sync with the lowest possible latency, while people still get the benefit of writing SQL queries. Because as wonderful as a system like Postgres is for transactional workloads, it is not capable, and it is not designed for, keeping up to date these more analytical, more complex queries up to date or materialized within milliseconds of the underlying data changing. It has a limited set of indexes that it can keep transactionally up to date. And a system like Materialize is designed to do, essentially under the hood, stream processing, which is necessary, but where the user doesn't have to manually do that just to keep a view up to date.
I want to go back to your wire compatible. We've talked about that a few times already. What has been, we talked about what is the insane part of Postgres. What has been the insane part of dealing with the wire compatibility or the wire protocol compatibility? Because there had to have been some weird issues to when you were doing the implementation to make it work, that you were probably banging your head at midnight trying to figure out what's going on.
The syntax choice for the semi-structured JSON is a little bit dated. It feels a little bit like a few too many special characters to subselect a field inside a record. It all makes sense when you take into account the considerations that they had to go through because of certain backwards compatibility. I love and I hate SQL. Right? I love it because you can get so much done if you're an expert. You can write so much in such a succinct, declarative fashion. But would I make different design decisions if I were coming up with a new query language from scratch today? Absolutely. I would make so many different decisions. That said, if you as a builder of a database start with, first I'm going to invent my own bespoke query language, that is not going to go very well in terms of adoption. People are very familiar with SQL, and within the constraints of having to use a SQL dialect, I think Postgres has made the harm minimizing choices in a way that is very principled. But I'd say the insane part is sometimes the frustrations of writing complex logic in SQL.
So which one are you? SQL 92? SQL 89?
We go further because there's constructs like the JSON ones that are relatively new that we have to incorporate. We try to hew towards Postgres compatibility, and I don't know precisely what the standard year that corresponds to, because Postgres makes a careful attempt and is very careful when they deviate from the standard if they do, but I don't believe it is precisely in line with one edition of the standard.
You answered with a serious answer to a really stupid question, so thank you for doing that. I cannot imagine having to, I'm going to stay on the WAR protocol for just a second. I can't imagine trying to keep that straight and up to date. And number one, who was the genius that decided to put JSON in a relational database to begin with? I mean, JSON in a database, that's fine. But as part of the, I don't understand.
It is no longer, I would say, it is no longer relational, strictly speaking, right? Like it is relational plus something else.
Can't we just go back to the old days when it was simple? We had 250 megabyte drives with a lot of spinning platters. Databases were simple then.
I don't know if that's true.
I strongly disagree with that. I had many nights trying to optimize my queries and database running on such simple systems. No, it was never easy. I would even argue that, and this is not only for databases, but valid for anything, things are easier today than they ever were. It's just that our requirements are very different. If I would want to do whatever I was doing 10 or 20 years ago, it's easier today than it ever was.
Let me ask that as a pointy question. When would have been the earliest time you could have built Materialize?
That's a fantastic question. Stream processing has made many technical advances, and part of the foundational technology of Materialize is a stream processor called Timely Data Flow, invented by my co-founder, Frank McSherry, who did some of the research in the early 2010s or the mid 2010s. So I don't know if you could go earlier than, and it takes a while to build a database, so you got to add a few years to that. So I don't think you could go earlier than, say, 2018, I think, is where the state of distributed systems was.
Okay, so let's go to the other side of this. These are not forward-looking statements. This is not a product roadmap. So you're thinking 2018. Where do you think the next hockey stick is going to happen?
Change data capture becoming a ubiquitous pattern, I think, is the next big shift. Folks who move, by and large, their ETL pipelines to acting on changes as opposed to snapshots, and doing so at low latency, I think is really the next step in the ubiquity of streaming data. Because it's a lot saner to deal with data coming out of an OLTP system at low latency. And now that basically it's table stakes feature for pretty much every OLTP database that is well supported and works well and easy to set up in, say, fully managed cloud databases, it's much easier to get to real time using that architecture than it is writing a custom microservice that writes to Kafka and has to deal with all of the various edge cases of what if my write doesn't succeed, or what if the transaction is aborted halfway.
And how long do you think that's going to be? 5 years?
I think it's happening. Yeah, I think it's happening.
It's in process now,
yes.
Right? But is it? But much like, I remember when indexes were new. I remember writing B trees back in the 80s. For other databases. So I think it's going to, like I said, ubiquitous. It's just got to be there, and you don't have to think about it. Actually, let me see if I can spin it a different way and see if you agree with this. It's not that so much that change data capture has become ubiquitous. It's that ETL is dead. Is that possible?
Batch ETL. If you restrict it to batch ETL, I would agree with you.
Okay.
Batch ETL creates all these problems because if you're dealing with snapshots, you have this data multiplication problem, which is 90% or 99% of the snapshot is stuff you already knew. And so you take what is a few 100 megabytes of changes, and now you're moving terabytes of snapshots around. You make your life harder in many ways. That's a big reason to move to a change data capture paradigm from a batch ETL paradigm.
So now we just have to convince all the AS400 people to do that. Maybe that will happen at some point in the future. Anything else you wanted to discuss? We'll talk about Materialize here in just a second too, but anything else that we've sort of skipped over that everybody should move away from MySQL to Postgres? That's number one. That's the number one thing I've taken away. Well, not number one, but It's in the list.
The pains of building and orchestrating microservices. Microservices are things, and I don't want to say you don't want microservices, but you certainly want to limit them to the ones where the value justifies the on-call rotation that it's going to need. Like, how can we move from 100 microservices where 90 of them are replacing fundamentally commodity uses to one where we have only the 10 that we really care about? The pains of orchestrating and running microservices is one that we haven't really touched upon.
I want to bring Victor in on this one because I know he has a specific thought on this. And we recently had somebody on the DevOps Toolkit channel from, I believe it was Fiberplane, to where this came up. We were talking about microservices. Victor, why don't you specify what a microservice really is? And let's see what Arjun thinks about that.
Let's say that it's an application that can be managed by a single team that is independently deployable and scalable from the rest. My main benefit of microservice is I don't care about the size, just to clarify from the start. Whether it's 1,000 lines of code or million, I don't care about those things. When I think about microservice, I think, can this be something that can be fully controlled, fully managed, everything by a team that is not bigger than 6 to 8 people? Because above that, I cannot work as a team anymore. To me, that's the benefit of microservice. Number one, managed by a single team. Number two, scalable independently of the rest of the system, right? Because we need those things. Now, the scalable part dictates in a way what is in a microservice, right? Because what is the part of the system that benefits from business logic being developed by the team, and what is the part of the system that should be scaled? The biggest problem of monoliths is I cannot scale it. I mean, I can scale it, but I need to scale everything. Oh, my registration is slow, hence I'm going to scale the whole system. From that perspective, there are operational difficulties with microservices that slow things down, but there are also advantages. Like, once I start being in conflict with everybody else in a company, I go faster, right? Technical constraints and so on and so forth. So I recognize operational difficulties, but if you do things right, we also gain on other fronts.
Absolutely. I think the that is an excellent point on the independent scalability, so you don't have to scale everything wastefully and multiply your infrastructure cost, because one dimension of that, it's like you have some n-dimensional beast, and one of those dimensions needs to increase, but you have to sort of proportionally increase all of the dimensions, and you have to pay for the total volume of your infrastructure. It's horrendous.
And also released, right? You don't want to wait for everybody else from all the stars to align for you to release a change to the color of a button, right?
Right. That resonates a lot with me, because at Materialize, we've taken a lot of care to have independently scalable systems. So we have a shared S3 backplane for storage, right? So everything that we store gets stored in the cheapest possible. So if you ingest data from Kafka or from Postgres, that gets written to an S3 bucket so that is stored as cheaply as possible. And you can spin up multiple clusters, right, which are compute units that can be independently scaled to host your materialized views. So you can say, create cluster foo, this is a materialized view, A join B. And then you have create cluster bar, which is A join B join C, or B join C join D. And then you can set and scale the sizes of those things independently, which is very valuable, because A join B might be very small, but B join C might be absolutely massive and need to be scaled out across multiple virtual machines and things like that. And so I agree with you that in fact that was one of our core design requirements, was preserving this independent scalability of different materialized views. It's a big reason why people have moved away from. I don't think, and again, to be clear, I don't think we need to move back to monoliths, right? I think you really want to move to something new, which is the best of both worlds, which has all the best features of both eras, which is the independent scalability, the deployment speed, as well as the operational simplicity. And again, I don't think we're going back to zero microservices. I want minimal microservices where they're truly justified.
Exactly. I mean, I think that the problem we have are those hype cycles where something potentially good is introduced, and that is equally value to microservices and anything else. And then people go crazy and think that that solves absolutely every problem and that it should be multiplied by 1,000. The other extreme, actually, of monoliths is not even microservices, functions as a code, right? Or serverless functions, which have very, very good use cases. There are quite a few examples where actually serverless functions are great, but then people rewrite their whole system into tens or thousands of functions and say, come on, you just got the tool, you just got the change, and you think that everything needs to be like that, right? But I have a question now that we mentioned microservices or applications, let's say applications, right? Whatever the size is. Where do you stand on databases in that relation? Because I somehow, from amateur perspective, like the idea that an application owns a database. Now, whether that's owns a user in a database or owns a schema, but owns a database, and everybody else needs to go through the API of that application to get something, right? Or put something. At least I had those horror stories in the past when random entities in random parts of the world or system write to the database, and then we need a whole week just to coordinate what will happen in a database if we release this.
This is where I think change data capture really shines, because I agree with you on the write path, but not on the read path, because there's a lot of people who want a up-to-date view of what's in the database, and they can get it from a change data capture stream that can be available as a service that anybody can tap into. But yes, a database should have a owner for the write path, absolutely.
Yeah. I was more concerned about writing. I don't care really who reads. I mean, excluding security concerns, who reads from the database. But now, in the past, we were solving that problem by saying, some coding patterns, and they say only this class writes to this and only that class writes to that. But I'm yet to see that in practice. People would inevitably start writing whenever that ends up being suitable, in a way, easy path in a way.
And then there's little surprises, right? Because you may have some constraints that are a foreign key check, and now you are having some dependencies that you didn't really know about. So it's really hard to, unless you really neuter the set of queries you're allowed to write, which kind of defeats the point, because the point of a database is to let the database do some of the heavy lifting to make your life easier, not to say, oh, you only get access to one table and you can write keys and values. Now you have to do all that heavy lifting yourself.
So Materialize is at materialize.com. All of Arjun's contact information is going to be down in the show notes. Arjun, thanks for being with us today.
Thank you so much for having me. This was a really fun conversation.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.